My name is Lianides-Chin. I'm here from Codance Full City. If you were hoping to be in Clay's session, then I'm sorry you couldn't get in, but thank you for coming here instead. I know I wish I were there right now. So I'm sure you're all wondering exactly what the session is all about. There's a few key concepts that are important to keep in mind as we're talking about why heartbeat checks and health checks like this are important. The end goal is resilience. We want systems that can automatically respond when the unexpected things happen in life. To get there, we need a combination of two other things. We need observability, which is what we can know about the state of a system based on the data it's already generating for us. A lot of us build our systems where they'll dump problems to logs or warnings, non-fatal issues might be written to a log file. We might be able to tell from the amount of traffic or based on the CPU load of a node that a system is about to be in trouble, but it isn't there yet. Observability is about being able to use all of those existing data traces in order to understand how your system's performing right now. And reliability is not just about, yeah, my system runs and it doesn't crash. It's about when I make this API call, it takes about 35 seconds to process, and I expect about 10,000 records. If I get 100,000 records back, or if it takes 300 seconds to finish running, then that's unexpected. That's not necessarily broken, but that is a flag that I might want to know and take a closer look at something that's going on in the system there. If you combine those two things, if I can see how the system's performing, and I know how the system should be performing, then I can get towards a resilient system where the system is able to take the unexpected in stride and either spin up more nodes if the CPU is getting overloaded, or retry an API call, or just notify a developer that, hey, this isn't what should have happened, so why don't you come take a closer look at it before the user sees that there's a problem. Who am I to be talking about all this stuff? Like I said, my name is Lianides-Chin. I'm a platform architect at Codance. For those who haven't heard, Codance just merged with Full City, so we're now still going to be Codance on the swag, but I'm actually working for Full City. I work across a variety of languages and platforms. So FileMaker is very much my day-to-day bread and butter, but I also do work in Python and JavaScript. We do containerization in Docker. We use Zabbix for system-wide monitoring. I do love sailing, so if you're ever up in Casco Bay and around Portland, Maine, then come look us up on our boat on the Harrisicot River. And if you want reruns, I gave a talk last year about how to use guard clauses to write more resilient code. So that's definitely worth a watch in my opinion. So the goal for this session is that when you walk out, you know how to make it as easy and cheap to add good observability to your system as it is to send an email. We all have that classic case. There's a report that's supposed to go out every day, comes in 9 a.m. in the morning every day. You delete it out of your inbox every day, and you might swear a little bit under your breath while you're doing it. And then one morning it doesn't come in, but you didn't notice because it's just noise to you when it comes in every morning. Heartbeat checks are about doing that problem properly, where you only get the notification when you don't get that email. So that email goes out every morning to the heartbeat system and it says, I'm here. And the heartbeat system says, great, I'm not going to bother the developer. The one morning that doesn't come in, the heartbeat system then tells you, hey, something went wrong. You should go check it out, hopefully before your users come into the office and notice. It should be as easy to do that as it is to add yourself to that email chain in the first place. Between the demo file for this solution and some of the techniques you're going to see demonstrated here, it will be as easy for you by the time we're out of this session. So I hope this is visible all the way in the back. This is basically a graph of a few different kinds of observability systems. So observability systems range in terms of how much signal or noise they have and how much they just notify you something's wrong, you need to take action, versus how much they can just kick off and self-heal and deal with themselves. So the big players in the space are those like Datadog and New Relic. You can see they're all the way on the right in the brown and pink spots. They have the tooling, the capacity, the engineered domain to be able to do very sophisticated things. They are also quite intimidating for the average FileMaker developer. It's hard for them to pick those systems up, especially when the only problem they're trying to solve is that they don't want that report in their inbox every morning. If you have a horizontally scaled cluster where you need to auto-heal if a variety of microservices aren't going quite the way they're supposed to, then absolutely, New Relic, Datadog, these are the right systems for you. If you're working at enterprise scale and you need to handle millions of log entries per second across a diverse array of hardware, Datadog is 100% your solution. But we need a FileMaker-sized solution for a FileMaker-sized problem. And for us at Codance, that has been healthchecks.io. To be clear, we're not affiliated with them. This is just a tool that we came across and started using in a couple of internal projects, and we liked it. So we tried it in a few client projects, and it was a great fit. And so that's the one I'm going to be looking at today. But this is not the only tool you can do this with. These techniques will work if you want to roll your own heartbeat system. They'll work if you're working with something like Datadog or New Relic or Zabbix, and you want to learn the domain for those tools and set up the service monitors for those tools. The same patterns in your application will apply in all of those cases. I'm just going to be demonstrating something that is the right size for the problem. I'm sure you all have seen this. These are the silver medal winners at the previous Olympics. And you can have all of the gear. You can have the sophisticated systems. You can be using Datadog and New Relic. Or you can get results that for the right problem are just as good by just sticking with the basics. And today we're going to focus on those basics. So why this particular tool? Why health checks? The main thing that I personally look for when I'm building an alerting or monitoring observability system is if it's going to alert me, my ideal is 100% of those alerts actually require my attention. There is nothing I hate more than an out-of-the-box Zabbix installation where 99% of the problems are things that I don't actually have to deal with. Instead, I have to go reconfigure all of the alerts so that it doesn't warn me when those things happen. With health checks, because you're controlling it at the application level, you can say, this is a process that I know I want to kick off every night. And if that process doesn't complete, or if that process runs into trouble during the night, doing some kind of batch process, then alert me. Of course I want to know those things. I get to choose when I'm programming the application how much I want the system to bother me later on if something goes wrong. The other thing that I like about health checks is out of the box you get a lot of integrations with it. There are other tools that have more integrations, but we use Slack, we use Jira, some folks use Trello or Asana. These are pretty common platforms that you would want something to happen in. Maybe it's you get a Trello card whenever the nightly batch process fails, and so you notice that first thing in the morning. Maybe it's you get a notification in Slack when that weekly email doesn't go out. So you know to check that on Friday, and it'll ping you and let your team know somebody has to log in and deal with this. I don't want to have to write the integration for Slack or for Trello or Jira or any of those. I just want to point the tool that's doing my alerting at those end systems. When it comes to automation, like I said earlier, there are systems that are better if you actually need self-healing systems. So in terms of health checks, it's not going to be able to make its own decisions about how should I respond to this problem. There are some ways you can use it as part of a pipeline in order to inform a system further down the line. So a health checks failure could kick off a process like adding another EC2 instance. But that's, again, not the typical problem we have in FileMaker land. And so that's not a typical problem we need to solve this way with automation. In general, we're better off with the developer logging in, seeing the problem and saying, oh yeah, we need to increase the RAM on that server. That's not something we want the system to decide for us. And that's the last point there. Does it provide structured output for downstream consumption? Health checks has an API, which means you can point another tool at it for polling, or you can add a webhook so that when certain events happen, health checks will send out a webhook notification, and that can kick off another downstream event. And those are the kinds of integrations that are really useful at this level. So if you're already sold, you can get health checks at healthchecks.io. You can download the demo file there. Actually, I'm not sure that link is working right this second, but in about half an hour or so, you should be able to download the files right there. And you can go try to get into Clay's session. I promise that no hard feelings. Like I said, I would be there if I could. We are going to continue on and talk a little bit about where does it make sense to use health checks? Where do you want to put these kinds of heartbeat notifications into your applications? And for that, I'm going to hopefully be on the right screen here. I'll just do that. All right, so this is the demo file. The README should be big enough for you to read in the back, but we're actually going to straight into the script workspace here. And I'm going to find my cursor again. All right, so inside this demo file, there's sort of two areas that you're going to want to look at. This health checks 1.4 module. This is the folder of scripts that we copy and paste into our other solutions. So when we want to install health checks or any kind of heartbeat system, this is basically all we do. We copy and paste the script, we copy and paste a few custom functions, and it's installed. It's not doing anything yet. You have to actually call it from inside of your scripts, and we'll look at how you do that. But it's not complicated to put this into production. There's a few basic config items. Hopefully this is big enough for you all in the back. But basically, you need to be able to say where is it supposed to send those alerts to. So in this case, we're going to health check system. So they use hcpings.com. In the bonus session, or the bonus part of the session, after we get through the core material, I'll actually show you how to spin up your own instance in Docker. And you can repoint this at a Docker instance. So if you need to run it entirely on-premise or behind firewalls, that's possible to do as well. You're also going to need to generate an API key in order to do pings. And I seem to have misplaced my browser. Bear with me for 1 second here. So once you log in and create an account in Health Checks, you will need to generate a ping key. So the ping key is the way that Health Checks knows these particular notifications came from your system and nobody else is actually trying to fill your log with junk data or artificially report problems or successes. You would treat it like you would any other API key. It should be in a password manager. You share it securely with any of your colleagues who need it. As a matter of practice, we tend to put this into a custom function because it's just convenient and easy to reference and not mistype that way. But you could put this into a data field. It doesn't really matter. You just want to make sure you generate it here, copy it, and put it in your solution. And so you can see that in this configuration script, I'm just grabbing the environment.secrets.healthchecks.pingkey, which is nothing more than a custom function. Apologies, my keyboard shortcut isn't working for that. I'll just close that and do it from here. Well, take my word for it. There's a custom function there. And all it is the string. It's just the API key that I generated and I pasted it into FileMaker. And again, if you want, you can paste it straight into the script here, or you can put it in data and point the script at that field. This is designed to be as configurable as how you like to store secrets in your solution. And then there's a couple of scripts. We'll walk through how each of these are useful. But the other important bit here is these tests. So we try to use test-driven development as much as possible. And so these scripts will just help you see, if I put in the configuration information, does it actually do what it says on the tin? If I submit a simple health check, then we find out if the demo gods are with me. I go back to my checks. Demo gods are not with me this afternoon. Well, I promised this was working this morning, and I'll show you some of the data from this morning. So you can see that this is the log of events in that particular check. So when you run that test, it's just going to send a simple OK This is basically an insert from URL step, and that's actually all that a heartbeat system like this needs. You send a simple insert from URL, the authentication is baked into the URL itself, and that way it's highly portable, lightweight, easy to move around between your different solutions. But there's some more advanced things you can do as well. So let's start with this extremely simple sample script. So in concept, this might be part of a nightly process. It goes to a layout, it tries to find the right set of fields, it does some stuff, and then it goes back to the original layout. If I want to add a check to that, I can do it at the start of the process. I can say, okay, first things first, I'm notifying health checks that this particular script kicked off. Here's my steps for that. I'm going to specify the name of the check itself, which again we store as a custom function for convenience and to prevent typos. And then I'm going to call the module single check-in ping. And that will send a single success signal saying this process kicked off at this time. I can see it came from FileMaker. I can even see which version of FileMaker it came from, which is useful if you're dealing with upgrades across client systems. And in this particular case, I'm talking about something that might be running on a server, but there's no reason you couldn't do this on a client as well. You could have this as part of your startup script. So you get a ping every time a user logs in, for instance. Then you also start getting traffic information. There are a lot of different ways you can use this downstream. But at its core, the most valuable function we've gotten from this really is about making sure that processes that are supposed to run actually did run and alerting us when they didn't. So here's another example. Let's see if this one works the way it's supposed to. So this is doing a start and end check. So maybe I've got a long-running batch process. I know it should normally take 5 hours to run. That's part of that reliability pillar we were talking about at the beginning. I can tell health checks when this process starts, and I can tell it when the process ends. So apologize, it's at the bottom of the screen, so it's going to be a little hard to read all the way in the back. Let me add a little spacing there. So another one of the functions in the module is this health checks stop check run. So because you know the start and end time of that through the check-ins, I have a started time here and an OK time here. I know that that process took 2 seconds. Any questions so far? Excellent. So in this example, we're taking the same thing we already did. We're just building up so we had it started and it finished. What if I want to note what happens inside of each section on the way? Maybe that batch process is doing 3 different things. And I want to know if one of them fails, but I still want it to do the other 2. Right? I don't want a fatal response. I just want to note that, hey, something happened you should pay attention to. There's a logging function here. So if you take a look at this one, and we'll dive into the calculation in a second, this is calling health checks log message. So this is the same basic thing under the hood. This is still just an insert from URL call. But along with it, I am passing that log message. That log message could be anything. It could be a JSON object. It could be a plain text string. It could be a FileMaker error code. It's up to me as the application developer what I want that log to be. I don't want to log a lot of data. Health checks actually has a ceiling. And again, for this kind of system, it's not meant for capturing your entire script parameter for every script along the chain. But it might give you the path of scripts that was called or the section of the nightly transaction that it stopped in so that you know exactly where to go to zero in on the problem. In fact, let's jump in and take a little bit of a closer look at that one. So you can see there's a few things in the anatomy here. Health checks takes care of these for you. But if you're rolling your own system, then you might want to just take a look at the architecture of health checks in order to understand what kinds of data are useful to build into your system. So here we've got the check name itself, it's nightly batch process. The UUID run is a unique identifier for each run of that process. So for nightly, that might actually just be your date. But if you have a high frequency script, something that runs every 5 minutes, or something that runs continuously, loops back on itself constantly every minute, in those cases, you might want to be able to actually use a get UUID so you know all the things that happened belonging to a particular run. Or if you have processes that might be forked, so maybe it's run using PSOS, and so it could be happening for 2 different users at the same time. Then again, you're going to want that unique ID so you can tell which pings belong to which specific run for which specific problem that happened. And the nice thing about this is I can set those at the top of my script, just like we did in the very first simple check one. So I've got a UUID, and I've got my check name. And then every time I call the module scripts below that, it's reusing the same information. So I don't have to be as verbose in describing it. It's just going to keep reusing that same UUID for the entire run inside of that script session. It's also data. So if I'm kicking off a process somewhere else, maybe I'm handing off from FileMaker to a PHP script. That PHP script can use that same UUID run, ping the same health check. And so I've actually got cross-platform health checks showing up in the same log data. Sorry, before I jump onto that. And then inside of health checks, this is what that looks like. So health checks has a log endpoint, which is how it knows that you wanted to log some data with it. It's simple body content. So again, the module handles all of this for you. We'll dive into exactly how those scripts work. But you can see in the request body there, I just have the name of the script that ran and an arbitrary log message. And so this by itself can be enough for me to know where to go look to start looking for a problem. The fact that I got a failure notice from health checks means I know there's a problem to look at. And this is as complicated as adding a couple of perform script calls inside of my solution. Right? This is about as easy as adding yourself to an email chain. So the last one here, looking at applications. Down here, let me see if I can get some more space on that again. I apologize, I did try to pull the resolution down. Is this hard to read in the back? Let me see if I can quickly get that. Nope. Yeah, I apologize with the WebEx share. I don't seem to be able to enlarge this very much. This video will be available in the recording. But I'm also happy to walk through any of these steps with anyone who wasn't able to quite see clearly how these are used in the demo file. So basically, I've got a check for an error message right here. So at the end of my script, I'm checking, was there an error thrown? If there was, then I'm going to use health checks fail with an error message. If there was no error thrown, I'm going to use health checks stop. Both of those will stop my run. So again, we looked at if you've got a long-running process, you can tell it the start time, you tell it the stop time, you can see how much time elapsed. If it should have taken 5 hours and it took 8, then maybe I want to take a look at it. If it took, 5 minutes and I got a failure message like that, then I know I definitely want to take a look at it. And when you hit that fail endpoint, that's the same as missing a check. The Heartbeat system will say, hey, this failed. I should go notify everybody who needs to know about that failure. Those notifications are done through integrations. So like I said earlier, in this case, I've got it set up for email and Trello. But you can add any number of integrations that are baked into the platform. And that includes webhooks. So like I said, you could use this to help notify a downstream system. Maybe I need to restart my FMSE processes if an overnight script fails. So I have set up a webhook for a monitoring system that just uses the admin API or uses the command line tools to restart FMSE on that server when that process fails. Maybe I need to notify somebody on Teams. Or Slack rather, right? So I send a message to my team that says this process failed. Somebody should go take a look at it. Somebody on my team can say, hey, I'm free, I'm gonna take a look at that. We've already coordinated more than the average email that comes into your inbox every morning. Or maybe it's a really critical system. Maybe I need to send an SMS so that somebody takes a look at it immediately. Again, out of the box integration, I can just say, here's the phone numbers to notify. Whenever that process fails to check in or receives an actual failure ping, then my team is notified immediately. Someone can jump on it right away, respond before the client sends us that angry phone call. That's an excellent question. I would probably try to use a webhook to do a Zoom integration. Teams is also one that's notably lacking. Yeah. Oh, I'm sorry, actually it's under M. But so there definitely are some systems that aren't included in here out of the box. For all of those, I would basically just use a webhook in order to make sure I could get into those systems. So whether it's Zoom, whether it's, not Trello, ClickUp, there we go. Whether it's ClickUp, whether it's one of the other systems that does project management, I want to create a new ticket. It might be an enterprise system where I have to have a ticket and it provides endpoints for it. The webhooks are pretty versatile, although there are limits to excuse me, how much you can configure the actual payload. So you may need an intermediary service. Does that answer your question? Great. All right, so before I show you the extremely simple scripts in the module, any questions about how to integrate, or any folks have thoughts about how you might like to use this in your systems that you've already got running in production? Going once, going twice.
I mean, it looks like it's just a, not to minimize it, but sort of an if error, then script step that calls a subscript.
Yes, so the question sort of, it looks like it's just, if there's an error, send an error ping, and if there's success, send a success ping. And that basically is what it boils down to. Again, we're talking FileMaker size solutions or FileMaker size problems. You can get more complicated than that. You can also use it in other creative ways. Like I said, one of my favorites is user login sessions. If I can see from the health check data that there were a lot of people logging into a system, that's great. But if I can see from the notification that nobody's logged into the system today, and I was expecting at least one person to log into the system every day, that is also an indicator that something is out of the norm. Maybe it's not a problem. Maybe it's just that everybody's at a retreat. But at the very least, I like to know that so I can go try to log in myself and see if there's a problem there.
My question there in that scenario is there where someplace you set the threshold for like one a day or?
Yep, great question. So the question was, where do you set the threshold for how often you're expecting those check-ins? So, sorry, let me back up a little bit. So this is the checks tab. Again, if you're rolling your own, I think that Health Checks has a pretty minimalist architecture, so it's worth taking a look at even if you don't want to use their service. Basically, they organize it into projects and checks. So a project can have any number of checks in it. Each check I like to correspond to one workflow or process. You can share them. Again, the system's not rigid. It's going to do whatever you want it to. But I find it easiest to say, my overnight script has this check. Not any server-side script has this check. Inside of the checks, there's a few things you can configure here on the left. So the first thing you'll note is you can actually hit the check itself with an insert from URL call, but you can also do it with an email. So while I prefer using our health checks module, in that instance that sort of sent me down this road of I'm sick of getting this report in my inbox every morning and I never notice when it's not there, you can replace your email address with the ping's email address and it will continue working just like it did before. You didn't really change any of the code. You just changed one value in a script. And now you get the whole richer ecosystem that comes with having a tool like this behind it. The schedule tells you how often you should expect the check and how long it should wait before it notifies you that there's a problem. So maybe there's some variability in the process. I know it takes about 5 hours for this process to run, but maybe it's give or take half an hour. So I'm going to set a schedule for once a day at this time, expect that check-in. But if it's not there until half an hour later, don't notify me until that half hour has elapsed. You can do that through the simple scheduler here, but Health Checks actually has a bunch of ways you can configure that for more complex schedules.
Can you do it through the API calls?
I believe so. I can pull up the docs for that in a second and we can double check. Another way you can do this, and sort of part of the lineage of the system itself, is through cron definitions. So if I've got a recurring process that I expect to kick off constantly, it's actually easier to write that as a cron expression and then say, if it doesn't happen every minute with a grace period of 2 minutes, then notify me that there's a problem. And if you've got a team that's familiar with Linux operations, they might be using, instead of cron, they might be using a newer expression system called onCalendar. HealthCheck supports that as well. As you can tell, the lineage for this system came out of recurring processes, mostly on Linux systems. So most of the time, in most FileMaker systems, this is all you really need. There was a question about whether the API allows you to set those schedules. So let's find out. It's the pinging API. I want the management API. Yep. So the timeout and grace values in the management API will allow you to set that for a script. So if you wanted to bake it into your FileMaker solution or whatever other platform you're using, that, oh yeah, I'm changing this setting. You know, my users are dynamically doing their own scheduling. And I want to make sure that the check is updated with that so it's not misfiring. Looks like you should be able to do that through the API as well.
My idea is that I want to call this the beginning, say that it's okay, the script started, and after 1 hour, I want to check if it's finished, or basically, or if it got a ping that the script was finished.
Got it. So you want to set at the beginning of the script, so along with your start ping, you want to update the check so that it says, I expect to finish in an hour, whenever it might have kicked off, because you don't know when it might have kicked off during the day. Is that basically right? Yeah. Yep. Yeah, so it looks like you should be able to do that. The module doesn't do that right now, but this demo file will be available. Feel free to update it, and if you save it back to me, I will update the file as well. That's a very interesting use case. I don't think that's one we've come across yet.
I have a solution for example, the script that is syncing with another system. It's like a stale state because of a cache issue or something like that with the other system, and then unless someone notices, it could be 4 or 5 hours without updating the data, and you don't have the real-time data.
Yep. Yeah, cache expiration actually is a really good example of when you would want a dynamic check like that. Any other thoughts, questions, thoughts about applications before we move on to look inside the module? All right, so inside of the module, there's these public API scripts, which basically just call the internal script. HTTP health check call. So inside of this private folder is where the actual work is done. Most of that work is really just configuring the URL. In fact, let me put this into code so it's a little easier to read. All right, so this is the calculation that is at the heart of the module that just figures out which kind of ping is it sending. If it has a start flag, it sends a start. If it has a fail flag, it sends a fail. If it's got a log message, it sends a log. Otherwise, it assumes it's just a simple check. And that covers basically all of the variations. There's a couple other ways you can do things by UUID instead of URL slug. In our case, it's just easier to do it by the URL slug. It's friendlier, easier for developers to remember, corresponds better with the custom function names. But this is, again, not a complicated system. This is meant to be simple and straightforward. And then if you look at each of these test scripts, so in the case where you're wondering about adding a call to the admin or the management API to update the grace period and the timeout for the check, I don't know if you would do that through the same HTTP health check call. That might become health check ping, and you might have an admin call. But you can see that you're just passing a couple of extra variables in to set the JSON object, right? So I've got the check name, I've got my start flag, and I've got the UUID of the run itself. There is one other fine detail here in the curl options. So for those of you who are familiar with API integrations, the health checks ping API expects either a get or a post. I believe it'll actually accept a post in all cases. I just happen to have initially written this using get. The post is necessary for sending a log message because it's expecting the body of that post to be the actual contents of the message. And it treats all messages as strings. So if you want to send a JSON object, you can just understand it's not going to actually wind up as a JSON object per se as a type. But if you pull that back out using the management API, then you can put it into some other system and parse the JSON. So the post is for log messages. Everything else goes in as a get, which also means you could run it from the command line using curl, or even in a web browser. If you want to test if your check is running, generate the URL in the script, copy and paste the result into your web browser, go into health checks and see if it worked. Let's see. All right. So that's all of the core functionality. As we were just talking about, if you want to add admin functionality, then you might have to extend this a little bit. If you want to add additional ping functionality or new pings come out, then certainly it's simple enough to add them here. But most of what you'll be working on is probably going to be in configuring your checks themselves, which we just talked about. So you've got your schedule, and then you can have per check notification methods that are set to on or off. These are drawn from that project level, where I set my integrations overall. So I define all of my integrations here at the project that send out the notifications if notification is warranted. And then inside of each check, I can turn off a notification if I don't want it going out for that particular one. But I have to say, I've never actually turned one of these off other than when I'm testing a script and I don't want to notify the client, for example, by email. So that's the core. You've still got a 15 extra minutes if you want to jump on the snack bar. I am next going to talk about how to do this in Docker so you can run it on-prem yourself. Before I move on to that, any other questions, thoughts, reactions? Get myself back into Keynote here. Oh, just a quick reminder, because I always forget myself. In Engage to Go, if you open the session, how to keep your app healthy and your users happy, please do fill out the session feedback. There wasn't enough feedback last year for them to actually measure anything. So please, it really does matter. It really is valuable. And as a speaker personally, I really do like knowing what I can do better for next time. So let's talk about on-prem. So this is fairly straightforward, but it does require not being afraid of the command line and knowing a little bit about Docker. So the entire procedure is actually on one slide. You can dig this out of their repository. This is basically drawn from their README. Just a quick show of hands. Who here has worked with Docker before? Okay, so maybe like 30% of the audience. So Docker is a way of running, to simplify it a bit, a way of running virtual machines on a computer. So on my laptop, I'm running Docker Desktop. It's what's called a hypervisor. It manages one or more virtual machines that are pretending to be Linux boxes that then run services like health checks. This is conceptually pretty similar to something like VMware, if you've ever worked with that before. Under the hood, it works quite differently, but the differences really don't matter for this application. So step one, of course, is going to be to, actually get the folder. Fortunately, I've already downloaded it, so we'll take a look at that in a second. The other important thing to do is to create your .env file. So .env files are a common way of storing configuration information. That'll be things like database passwords, email servers for SMTP configuration, all the things that you want the application to know. Often services like this don't have a GUI for setting up that kind of configuration information. Instead, you put it into a text file. So let's take a look at some of those text files. Don't need to save that. So to start, is this visible to everyone in the back? Great. This is a Docker Compose file. This describes the services that you want to run. It can get a little confusing because services are sort of nested here as terminology. So I want to run the health check service, which is something that my FileMaker application or PHP app or whatever it might be sends pings to. The health check service requires a database and a web worker. Those are split out. You know, not every system is as effective as FileMaker in putting everything into one spot. FileMaker is very nicely vertically integrated. Health checks is not because it's built on a different underlying technology. It's nice because I can run it in a Docker container like this and actually handle quite a bit of scale. But it does require that I have both a web worker, which is defined here, and a database worker, which is defined here. This is the stock Docker Compose file. So you don't have to write this. You don't even really have to understand exactly what it says. You just have to know that this is in the Docker folder of their repository, and this is what you're going to be running against. The other thing you're going to need is they've got an env example here. Like we said, env files are essentially how you define configuration elements for services that don't have a GUI for defining them. So it's common for repositories to have an env example. One thing you basically never want to do is actually share your .env file itself, because it's often going to contain things like your database password. That's not something you want in your Git repo. That's not something you want to be emailing back and forth in an unsecure fashion. It's not something you want hanging out anywhere anybody unauthorized could possibly get at it. So treat your env files like they are passwords themselves. If you've got to move them around, I like to just drop them into one password. That's how we share credentials around between different developers. Shared drives, if you've got OneDrive or Dropbox or something like that, also perfectly reasonable. Just make sure you're using an access control system, somewhere you can ensure only somebody logged in who is authorized to get that file can actually reach it. So this env file is basically made by just copying and pasting theirs. You can see the information is essentially the same. I didn't even update the passwords. So let's get this up and running. For convenience, I did write a little script that does a couple of different things here. So the first time you run it, the command line you're going to run is this docker compose up. That basically tells Docker that you want to use that Docker Compose file that defines the services. After that, you're going to need to run this line. This is specific to the health check service. So Docker compose up you would use for any Docker service you're going to run. It's a universal command. This specific one is how you set up your first user account to log into the health check service specifically. This again is just taken from their README, and I copied and pasted it here for convenience. And then using the default configuration, you're going to be able to access the health check server on your local host at port 8000. For simplicity, this is just a developer version of this configuration. You can build on this to actually run a production version. So you can run it on a domain that's got an SSL certificate that is actually using a proper database password, not just Postgres or password. Obviously you want to make sure that this version that's coming from the demo is not something that's exposed to the public internet because it's exposing an unsecured server. So let's go ahead and run that. All right, so we don't have to get into detail about this, but basically it pulled the pre-built image down for the database server. It built the web worker out of the repository that I cloned, and it created the necessary back-end virtual hard drive. And I'm going to just add my initial user. And there we go. I'm now running my checks instead of health checks. And there we have now a fully functioning version of the same health checks process, but this one's actually running on my laptop. I am going to need to create that ping key we talked about at the beginning. So when you create a new account in health checks, you do have to set up that ping key at first. I'm going to copy that in, and we're going to go, I'll just paste that in here manually. Right, so I just updated the ping key in my configuration script in the module, so now it's going to run using that instead. I do have to do one more thing, which is to update the destination. So you can see that my base URL here is actually my server port 8000/ping. It's a little bit different than the one that's built into health checks, where it's HC ping and then the ping key. Just something to be aware of if you happen to be running it locally or running it using Docker. That you have to get the entire base URL, not just the host name. I'm going to update that here. Oh, my disable shortcut isn't working either. And now, if I send a single check-in ping test, nope, we're running into that same problem we were before. Oh, I don't have developer tools turned on. That's why none of that's showing up. Let this be a lesson to never create your presenter profile the day you're doing the presentation. All right, trying that again. We'll actually follow this one through and see what's going on. A little live debugging for your afternoon. So you can see we're now in that simple check-in script that you would call if you were trying to send a ping directly. That's going to then call the underlying HTTP script. And I'm just going to jump down to the point where I get my URL. Let's take a look at that. So just so it's visible all the way in the back, This is the URL it created. And apparently I somehow added a space, which is why that's probably not working. Yes. Thank you. And there it is. Thank you for that. Oops, that's the... There we go. So with that fix, so we're actually calling the right URL now. You can see that I just got a check-in and it created that check. That check wasn't there before. So one of the features of health checks is if you send a slug that it hasn't seen before, and you have a parameter that says create a check for any slug you haven't seen before, then it will automatically create it for you. This module has that turned on by default. It's hard-coded in because there really hasn't been a use case where we didn't want that to happen. The only time you might not want that to happen is if you're not able to sort of set your slugs themselves as a constant, then you're trying to guard against something like a typo. But as long, in our cases, we're using the custom function to define the slugs, then we're never going to have a typo. And so we basically always do a new URL on purpose. Question?
Yeah, so when it comes to managing multiple files, we want to make sure to have these health checks. How do you manage that? Is it just through the big?
Yeah, so the question was, if you've got multiple files and you're trying to manage health checks across a set of files instead, how do you make sure you've got the right configuration information? So there's two ways you could go about that. One would just be to copy and paste the custom functions across. Your ping key will never change until you revoke it. So once you set that with the account, that's always good until you change it. And if you've got it in a custom function, it's fairly easy to update it across multiple files. Though obviously if you're an SBA or somebody with a large number of deployments, that could get a little bit more annoying.
How about managing multiple clients? Like, do you normally keep multiple accounts, like health checks accounts, or clients, or one would manage all of them?
Yeah, so in our case, we typically set up a health checks account for each client. Sorry, the question was about managing multiple clients. How do we actually organize that? One of the reasons for that is we want to make sure our clients have access to this dashboard, and that if they want to take ownership of it at some point, many of our clients have in-house development teams. We want to make sure there's no friction for them to do that. Sometimes when we're doing initial development, especially if it's on our dev server, we might do it in a shared account. And then in that case, we'll make the client part of the slug. And then when we deploy it, maybe we might just leave it in there. It's pretty harmless. But if we wanted to tidy it up a bit, we would just edit the slugs in the custom functions. In multi-file deployments, which I think is a little bit different than your original question. But if we've got a system where you have multiple back-end files or controller files for one unified front-end interface, that's where we might actually put the ping key and the slugs into a database and make them data that's accessible from each of those files, so they'd all have access to that table. Or one system we've used also is to just put them into a secured S3 bucket, and then each file, when it opens, downloads the information from the S3 bucket as a JSON object. There's other, especially that last one is a little bit of a cheap workaround. There are other more sophisticated ways using actual secrets, vaults, and managers. So if you are commonly looking at that situation, that might be a time to look at a real secrets manager, something like one of the AWS services. Does that answer your question? Excellent.
Do you have tools to look at kind of the aggregate data, the log data, to see for a time period how many errors you have or logins?
Yeah, so we haven't had to do that at large scale yet. Mostly it's been during system rollouts, or right after a major upgrade, where we're just sort of manually inspecting the data because we don't need to have it in aggregate. At Codence, if we needed to do this sort of in a longer term, more repeatable fashion, we've actually got a product called Genesis BI. It's an ETL, and it's sort of like Tableau Lite. So if we needed to do a visualization based on it, we'd probably set up something like that, where we just gather the data using that administrative API, process it into some kind of data warehouse, and then use that data warehouse to power a dashboard system. And that could be Genesis BI, that could be Tableau, that could be a CSV file that has some graphs on another tab. Again, the goal here is to keep things as simple and functional as possible. And so we sort of only build out that kind of complexity when we've got a good recurring case where we need it. Does that answer your question? I'm gonna see if I can get this mic on. Any other questions that I can hand somebody a mic for? No, everybody's afraid of the microphone. It doesn't bite, I promise. All right. And then the last thing to look at for our bonus content is just taking down the Docker system. So again, this is just as written a production system, a development system. You wouldn't want to run this in production. So when you're done with it, all you need to do is Docker compose down. And the -v flag here, as I discovered last night, is really important if you want to erase the volume that the database is on. So if you do Docker compose down, it will actually persist your data the way this compose file is configured. So the next time you try to spin it back up, maybe you downloaded an upgraded version of health checks, it'll still have your login information, all of the check history. Again, a nice feature of Docker is that it has this persistent option, even if your containers, the virtual machines are erased. But if you want to really clear all traces of it off your system, you're done testing, you're ready to put this into an actual production system pointed at a production scale deployment, you want to make sure you use that -v flag to actually erase the volume from your hard drive as well. So that is just about time. I'm going to pull that down. So that's how to keep your app healthy and your users happy. Any other questions, thoughts, perspectives? Going once, going twice. Cool. Thank you all very much. Please do remember to fill out that survey. We really do value that feedback. And if you have any questions, again, my name is Lianides-Chin. I'm from Codence, and you can find me at that email address right there. Thank you all. Have a great night.